managed to solve. I solved on-off, and I've very nearly solved set time. I have a problem that I can't set an enumeration value, so my minute button increments by an hour, but other than that it works, if that makes sense to people. At the top of I'll just walk through my transformation in order. It's basically the order I wrote it in, so it should kind of make sense. At the top I have some traceability classes, so a specification maps to a configuration, mode maps to a, actually, strictly speaking, the combination of a specification and a mode name maps to a mode. The combination of a specification, a mode name, and a button name maps to a button in the target model, and an observation maps to an action. There is other traceability throughout the Tefkat transformation, but it's implicit. When I've got an explicit traceability class, it's because I want to refer to it back later, but every correspondence from source to target is recorded. So first of all, I've got a simple rule to make a configuration out of the specification. Linking establishes the traceability, which I can refer to later. Just as a quick intro, Tefkat is logic-based. These rules apply automatically. We've got a stratification thing where they work out their application order automatically. You don't have any ability to call other rules. The ordering is weakly linked through the traceability thing. So a rule that makes a traceability thing will be invoked before a rule that might consult it. So I create some modes. I actually look for check modes, observe modes, and enters modes, and if any of them mention a mode name, then I'll create the mode in the target model. Similarly for buttons, although I actually turned off the press button rule just because it wasn't being executed anyway, but I could uncomment it, it would work. For button order, Tefkat has a logical statement to say one element is before another element in a collection, which gives us partial orders, which we can both check and assert. So what I've done is I've got a little pattern which says name order, button name 1, button name 2, and if it finds any of these, then it will assert the order. If you use arbitrary names, the order will be non-deterministic. It will be some other order, but I put in these ones, so if it finds things that it thinks should be in order, then it will order them according to that list. So that pattern's just referred to here in a rule which does the button ordering.
So if you have first and third,
then
you find the order?
No, actually I won't. But I can rewrite that pattern to do that. That would make sense. It's a good idea. It would be. I mean, it's a logical constraint. It would be fairly easy to rewrite that. So. Now I have a series of rules which map observations into actions. And what they do is they kind of just create the actions, and the actions float, and then float around in the model, and then there are other rules later on which wire them into the correct place as an entry action or a behaviour of a button. So there's actions to display something on, to print a constant on the display, to print a variable on the display. I probably could have abstracted those rules a little bit, but they work. Observe variable change, so this is part of set time, obviously. Time variable condition is a condition. Conditions, the way I did it in this case was the condition looks up the action and ties itself to the action, but another option would have been to just create the condition and have it float as well, and then have some other rule which linked the condition and the action later on.
Point to the links, Jim, and show them what
Oh, this part?
Yeah, just show them the syntax.
So this is how I look up a traceability link. So this is where I check whether a traceability link exists. So in this case, I want to find the configuration that was created from the specification, so I can use it further down. And that's as opposed to this, the linking. So a linking statement establishes a traceability thing, and a links statement is where you can check it. I've got a little bit of math stuff in here to sort out, so what have I got here? This int statement here is what casts from a string to an integer. And I've got a little bit of maths to, I didn't actually split the string, I did modulo on essentially modulo on the integer to get the last 2 digits, so I could actually do 100 hours if I wanted, but it makes no difference. Println is just a debug trace for me. what I have on the target side is I can either make logical statements about what type an object is and what its properties are, or I can do this kind of pattern syntax here, which I guess a little bit like a JSON or an HUTF or something like that. The from statements in here, these control how many things are created. So this make clause is saying make me a variable in this place, and I make the same variable. For example, if it's time, the time variable, I just say make it over and over again and just put a from statement saying it's created as a function of the specification and the variable name. So if I say 100 times make me a variable called time, it'll realise that I've already made one and it'll just register the same one. So that from statement is what we call injections. They control how many objects get created. And I use those in a bunch of places for making sure I don't make too many modes, making sure I don't make too many buttons, making sure I don't make too many constants, variables, that sort of stuff. And you see down here, rather than using that kind of template syntax, I've just got sets which establish facts in the meta model. This is for the unmoded actions. So these are actions that are not where you don't have a check mode clause at the start, because you want to wire them up a little bit differently. They want to belong to the configuration, not to the button or the entry mode. So I just pick that up, because otherwise those actions will just be down. Create an alarm action. So this was something I did right at the end when I realised, oh, I haven't actually done the alarm part because I didn't read the clause. But the nice thing is, so to extend my transformation, I just make a new alarm action and link it with observation to action, and then all the rules that were picking up observations and putting their actions in the appropriate place in the target model, it just picks that up. So it's nice and extensible in that sense. Yeah, entity mode actions. Yeah, that's going to be fun. I've got this, sorry, I'll be very, very quick. Next mode orders just puts the mode in order. Because I'm using partial orders and we've got a full cycle, it's not actually possible to calculate a total order from a cycle of partial orders, so I actually have to I have to not generate a partial order for the last transition to make sure I can actually get a total order out of it. Other than that, yeah, it's about 250 lines with a few comments in there, with the trace model in there as well. These are the models that were generated.
Okay. So are there any questions?
Yeah.
Can we see the stratification?
Can you see the strategy? Yeah, we can
Yeah,
actually.
it's that.
Yeah. That's a very good question.
Bottom tab, in that,
No, it's this one.
ah, sorry.
Yeah, I haven't even looked at this. It's a good question. One that it's single level. Tefkat has some fancy continuation, fixed point continuation semantics in it, which will even if you end up with a lot of rules that sort of refer to each other, Tefkat can usually just work it out. It's very rare that you find. There's some conditions where you look up traceabilities with negations where you can find that your transformation will flounder, but it's very rare and it's usually not what you want.
Mostly I've written lots of Tefkat now and I never know what stratification to expect, and I don't really care because it doesn't usually, it's under the covers.
Well, it's interesting that it's single stratum. I would have expected
Yeah,
two.
me too.